At the moment, I'm going to discuss connecting a MicroLogix1400 via I/O to a CMMS-AS Festo controller. This is a standard layout right here, and we're using the I/O on the top of the CMMS over here, connected to the I/O of the 1400 over here. And for this application, we've got a FCT project consisting of a axis, motor, and controller. The control interface is digital I/O. Horizontal, we've got a load, and we have a 120 volt hookup, so it's important to know that the under voltage should be set a little bit lower here. Some limitations for min and max. Some over travel for software limits. Here's our firmware number. Our gains are based on our load that we entered before. It's really important for this particular application that you have the digital I/O, or at least in this case, the digital outputs configured as I have here. Otherwise, the code that I'm providing will not work. That's the sample. And the handshakes won't work. And the next thing is my code executes records 1 through 7 and then continues to sequence through them over and over again. So it's important that you have programmed and downloaded all this and you have at least 7 records. The rest of the information is really of no value for the time being. Okay, so now getting into our PLC motion, I have main routine with a bunch of jump subroutines. I've got safety. So on the X1 connector again, this connector right here, there are some signals that are related to safety, and one of them is called power stage, one of them is called controller enable. The sequence of operation for turning them on and off is such that the power stage enable gets turned on first, and thereafter, with a minimum of 20 milliseconds, the controller enable gets turned on. Anytime that you are using the FCT configurator online and you have this checkbox down here, the FCT, or you've enabled it, normally to get the access back into the hands of the PLC, the control sovereignty has to be passed to the PLC. You need to, of course, be online. And toggle the bit off, toggle the bit back on so that you get the controller enable. And at this point, we are physically power stage active. Again, I'll show you, turn this off, turn it back on. The power stage is not active because FCT had last control. In order to get that back, either you have to turn the controller enable off, or in this case, I'll just turn everything off as if I'm hitting an e-stop. As soon as I do that, I get the power stage back. So that's very important. In the FCT, you've got the operate tab at the bottom here. It's more so important to test and make sure everything works within FCT before moving into the PLC code. Going back to the PLC code, we have our safety, ladder 16. That was something left over, I don't need that. We have motion block. So we have a safety rung. This is required prior to sending any command. So this is what we call, automotive like, is it's a 5-rung motion block. And we've got a precondition, in this case, we're setting record numbers. And then in the command, we're going to confirm that the record number was set. And latch in the fact that we're commanded. We are then we are going to latch in the fact that we've commanded it. Then we wait to make sure that start task is on. The handshake is the acknowledged start. Once the handshake comes in, then we know that the move is active. Then when the move is active and we get our motion complete, we know the move has been completed, which is there. That's a typical 5 rung. So if you look at this right here in itself, there's common code here, which is the start task. And basically each 5 rung is going to be a command and not active. So again, down here we have a command. So we've set our record select bits, our binary select to the controller. We latch in the command. At that point, the latching command and the fact that you're not active turns on the start task. Start task gets turned on. The handshake will transition, and that's your handshake. You now latch in that you're active. Now that you are active, you wait for your motion complete. When your motion completes true, then you are complete for that particular move. The sequence that I have written here is such that you get a bit to say move execute. I wait for the record to be complete. So execute, not complete is your precondition. So execute, waiting for my complete. This is my complete, and this is how every move is set up. This particular one, at the very end of the code here, if I go to the very end of this, I have when the sequence is complete or I'm not in auto, I unlatch all my bits from my motion blocks. And when all of them are unlatched, I have this one global bit to make sure that they're all lot. And I'm using this bit up here to make sure that everything's been reset before starting a new sequence. No leftover latches unturned. Okay. The IO map routine here is made so that the code is a little more portable than normal. This here is the physical IO. Could be any physical IO as far as your wiring goes. These are the bits that are being used throughout the program. So you have your 4 inputs. These again will match the outputs right here. Okay. And then I have my map outputs, which are the binary selects and other various things. So these bits over on the right here are the outputs. These will have to be modified so that they match your IO on your PLC. And if I go to the sequence here, if I toggle this bit, nothing happens. Well, homing valid. Oh, helps to be online. Save changes. Cancel. Just going to download the code because I made that one change. So, power stage is active. We are in fact homed. I don't have a homing routine in here. And toggle this bit, and you will see the code executing time and time again. If I go to the common code here, you'll see that it's bang, bang, everyone bang, bang, bang here. And you can watch the individual blocks working. And that's it. And you can hear the servo working here. I have relay outputs on my PLC. That's what you're hearing, going click, click, click. And the motor itself is making the squealing. And that's it. This is our PLC program, very basic. Thank you.